In this video, I'm gonna talk about STP or 802.1d and RSTP or 802.1w port states. So as you can see here in the notepad, I listed the STP states or port states, and you can also see the RSTP port states and whether those ports and those particular states forward frames or not, and whether they can learn the source MAC addresses of the received frames, and the duration of the duration of how a particular state, for example, listening, how it transitions to how long it takes to transition to the learning state and learning to forwarding state. So here, so right now, and also we have a topology here. We've got 4 switches, and let's see what version of the STP these switches are running right now. So we can go ahead and check switch 1. So you can actually do just a show spanning tree command to see all the states of the ports. So here, this is actually the root bridge or root switch, as you can see here. So we only have one VLAN. So generally the root switch, root bridge, its ports are all designated ports, and those designated ports are all in forwarding states. So here, all its ports are designated ports, and they are all in forwarding states. So, and it's, like I said, it's running the IEEE 802.1d, says here. So next, let's check switch 2. So I'm gonna do the same command. So here, let's check the connection going to the root bridge. So gig 101/0/4, that is this is actually the topology that I used when I did that when I discussed the spanning tree, root bridge, and port election process. So these switches, I labeled each port on these switches. So as you can see here, all the ports on the root bridge are labeled designated ports. And here, this port is labeled root port, and this one going to switch 4 is labeled alternate or blocking port, and this one is labeled root port going to the root bridge, and this one is designated port going to the switch port. So let's go back to switch 2. So gig, like I said, gig 1 1/0/4 slave is actually the root port, and its state is forwarding, and the gig 1/0/5 is alternate port, meaning that it is the alternate port, just in case the root port goes down, alternate port to get to the root bridge. And alternate ports are usually in blocking ports, blocking states, as you can see here. So basically, designated and root ports are both in forwarding states. So we are, focused. We are focused on the port state in this video. So we're gonna talk about the port states. So let's check switch 3. So it's got a root port and a designated port. So let's verify that. Yeah, it is. It's gig 1/0/0 is the root port, and it's in forwarding state. And it's gig 1/0/4 is the designated port, and it's in forwarding state. And last, let's check switch 4. Show spanning tree. So it's gig 1/0/1 is the root port, which is in forwarding state, and its gig 1/0/4 is the alternate port, and it's in blocking state. So like I said earlier, these switches are using the IEEE 802.1d, or the standard STP. So, and we have checked all the states here. So we have checked the blocking state, which is the state that an alternate port is in. Listening and learning state, these are just transitionary, if I'm not mistaken, states. So, and forwarding state, these are the state that the root and designated ports are in. Disabled state, this one is actually, you cannot see this, of course, because when we do a show spanning tree command, because this state here, this is admin down. The port is in admin down state. So let's look at RSTP state, port states. So as you can see, all the STP states, disabled, blocking, listening, are combined into just one state, and that is discarding state, as you can see here. And learning is still learning, forwarding is still forwarding. So what I'm gonna do a little later is I'm gonna actually set or configure the spanning tree as RSTP. So we're gonna check the states of the ports after we have configured the spanning tree as RSTP later. So forward frames. So of course, disabled, blocking, listening, and don't forward frames. Learning, don't forward frames. and learns a port learns source MAC addresses of received frames. So these port states don't receive the source MAC addresses of the received frames. Learning state, a port that is in learning state does receive the source MAC address of the received frames. Of course, because the port is trying to learn the source MAC address of the received frames, and of course, forwarding state learns the source MAC addresses of the received frames. And here I listed the duration, so how long a particular state transition from one state to another state. For example, the blocking state takes 20 seconds to transition to the listening state, and listening state takes 15 seconds to transition to the learning state, and learning state takes another 15 seconds to transition into the forwarding state. So let's check the switches and configure the span entry as rapid span entry. So the way you configure it is by doing a span entry node. Let's do a question mark. So rapid PBST. So I'm gonna do this to all the switches. Span entry node. Oops. Span entry node rapid. And we will check the states of the role and states of the ports. Let's save the configs. And last is switch 1. So let's check the role and state of the ports on switch 1 after we have configured span entry as to run as rapid span entry. So you can verify that a switch is running the rapid span entry by doing a show span entry and just looking at this portion here, span entry enabled protocol RSTP. So the root bridge has not changed. This is still the root bridge, and I believe all the ports have the same roles and states. So let's verify that. So as you can see here, all the ports on the root bridge are designated ports and are all in forwarding states here. Let's check switch 2. Show span entry. So yeah, the roles have not changed. The roles of the ports have not changed. So if we look at the table here, it says that that an alternate port is in discarding state This is not actually what's happening here. We are running RSTP spanning tree. RSTP, and the port that is in uh, that is alternate uh, here is not actually in discarding state. Still, it is still in blocking state. So designated and root ports are in forwarding states, like what we've seen in what we saw on switch 1. Let's check switch 3. Show spanning tree. So this also running. This switch is running RSTP, and it's gig. So the port roles and states haven't changed after we configured the switch to run RSTP. Let's check switch 4. So yeah, we are seeing the same on switch 4. So still the gig 1/0/1 is the root port, and it's in forwarding state, and this port here is the still the alternate port and is in blocking state. So we have verified that after we have configured all the switches to run RSTP, the alternate ports are not actually in discarding states. But uh, there's actually, but the function of the ports that are in alternate port combine uh, all these states, so they become just all these states just uh, are combined into this discarding state if you are if a switch is running RSTP. So yeah, that's it for this. That's it for this video. Thanks for watching. Bye.